Hello. Well, in today's lesson, we're going to learn about roots. And the first thing that we're going to see is what is a square root, right? A square root of a number is one of its two equal factors. Let's do it in algebra. If x to the square is equal to y, then x is the square root of y. Let's see an example with numbers. Right here, we have a 5 squared. It's equal to 25 because 5 times 5 is 25. So 5 is a square root of 25. In this case, a perfect square is a rational number whose square root is a whole number. Complete the table for the following square roots, the perfect squares. And we have a table right here. You have it in your books also, so you can see it right there. And it says a perfect square is a rational number whose square root is a whole number. And we have to complete the table with the following perfect squares. So if you see a pattern here, 1 times 1, it's equal, 1 times 1, it's equal to 1, right? So this is our first perfect square root. 2 times 2, it's equal to 4. 3 times 3 is equal to 9. 4 times 4 equal to 16. What number times itself, it's going to be equal to 25. Okay, so this is easy. 5 times 5, it's 25. What about 36? What number by itself multiplied is 36? Well, if we follow the pattern, you'll know it's 6. 6 times 6 is 36. What about 49? Well, a 7. 7 times 7 is equal to 49. And 64, it will be 8, right? What about the next one? Okay, the next one will be 81. 9 times 9 is 81, right? So the perfect square is that number that when we multiply it by itself gives us a number, right? So if I multiply 10 times 10, my answer will be 100. So I can say that 10, it's the square root of 100, right? Good. Let's continue with this part. Every positive number has both a positive and a negative square root. Okay, so right here, since 3 times 3 it's equal to 9, we can say that 3 is a square root of 9. But also, negative 3 times negative 3 is equal to 9 because negative times a negative makes a positive. So negative 3 is also a square root of 9. Therefore, 9 has two square roots, 3 and negative 3. So every square root has a positive and a negative number. Good. In most real-world situations, only the positive or the principal square root is considered. A radical sign, this one right here, okay, is used to indicate the principal square root. When both the positive and the negative square roots are asked for, this symbol right here appears, okay? Positive and negative symbols is used before the radical sign. So we call this the radical sign. If we have only the square root or the radical sign by itself, it means that we only have to put the positive square root or the principal square root. In this case, the square root of 25, it's 5. What about when we're asked to put only the negative of the square root of 25? So my answer would be negative 5. But when I'm asked to put the positive and the negative, okay, I have to give two numbers, the positive 5 and the negative 5. Oh, my 5s look very ugly. Let me do them again. I see. It's ugly as well. So I need to put the 5 and the -5. Okay, I'm gonna put them a little bit bigger so you can see. And when it's positive, we don't really need that sign. We only put the 5 and the -5. Good. Let's see an example. This example tells us to find, or to simplify, I mean, the square root of 64. If you see, we only have the radical sign, okay? So in order to simplify the square root of 64, you need to determine what number multiplied by itself equals 64. Let's find the factors of 64. 64 can be divided by 2, and we get a whole number. It can also be divided by 4, and we can get a whole number. We can also divide it by 6 and get a whole number. Can we? I mean, we can't, right? What about 8? We can divide it by 8. Let's see. What would be another one? If we look at one, so another one would be 16. Let me check it right here. 64 divided by 16. Yes, it's a 4. And also 32, it's a factor. And last, 64. So one of these numbers multiplied by itself can give us 64. We know that 8, when we multiply it by itself, it's 64. So the square root of 64 is 8. Okay, very good. Let's see another example. In example number 2, it's asking us to find both square roots. If you see here, we have the symbol that asks for the positive and the negative of 1.25. Now, we have a decimal right here. What we need to do, it's, let's see, step 1, since there is an even number of decimal places, consider the square root of 121. Determine what number multiplied by itself equals 121. Well, it will be 11. 11 times 11, it's 121. Let's go to step number 2. We already know that 11 by 11 times 11, it's 121. But our number is 1.21. Okay, so we need to decide whether we need to put the decimal point in between the ones or in front of the ones. Let's see. So it says there are only 2 options for placing the decimal point in the number 11, either before each digit or between the digits 1 and 1. Since 1.21 has 2 decimal places, then the sum of the number of decimal places in each factor must be equal to 2. If you multiply 0.11 times 0.11, then the product will have 4 decimal places, okay? We have 2 right here and 2 right here. When we multiply them, we add the numbers, right? If you multiply 1.1 times 1.1, then the product will have 2 decimal places. If we see, we need to get the square root of 1.21. We need 2 decimal places. So my answer would be positive and negative 1.1. Okay, that's very important. Let's see another example right here. And it says, find the negative square root And it says simplify square root of 25 over 36. What we need to do is we need to find the square root of each of the numbers in the fraction, okay? We need to find the square root of 25, which is 5, and the square root of 36, which is 6. So the square root of negative square root of 25 over 36 is equal to negative 5/6. Okay, we only do the square root of both numbers. It's pretty simple. Let's continue. In example number 4, we need to find the square root of negative numbers. And it says simplify the square root of negative 16 using rational numbers. Okay, if the expression cannot be simplified, explain why. In order for us to simplify the square root of negative 16, we need to determine what number multiplied by itself equals to negative 16. There is no number, right? There is no rational number square root of negative 16 because a number times itself is not equal to negative 16, right? So because, how do we put it right here? No number times itself equals to negative 16. So negative square root of negative 16 cannot be simplified and has no rational number solution, okay? Any number, we cannot have any number multiplying by itself and get a negative number, because remember, a positive times a positive, in this case, let's put number 4. 4 times 4, it's equal to 16. But negative 4 times negative 4, it's not equal to negative 16. It's also equal to positive 16. So there is no number, okay? So we have to say that there's no number, there's no solution. It cannot be simplified. Good. Now, let's learn how to use square roots to solve equations. You can solve equations by using inverse operations, okay? Inverse operations undo each other. Squaring and taking a square root are inverse operations. Now, to square a number, we multiply by itself, right? So 9 squared, it's equal to 9 times 9, which is equal to 81. Now, we need to take the square root of 81. What number by itself, multiplied by itself, is equal to 81? So it's 9. So if you see, it's like the opposite, okay? To solve an equation of the form x squared equals p for x, and do the operations of squaring x by taking the square root of each side. So we have here x squared is equal to p. So we need to take the square root of x squared in order to find p. We also do a square root of p. So x is equal to positive and negative p. Okay, let's do it with numbers. Let's find an example right here. It says use square roots to solve equations. Solve t squared equals to 169 and check your solution. So t squared, it's equal to 169. What we need to do is we need to take the square root of t squared and the square root of 169. When we take the square root of a number, the squares are eliminated. Okay, so we only end up with a t. And we need to find the square root of 169, which in this case, it would be positive and negative 13. So t, it's equal to positive 13 or negative 13. So there are two solutions for the equation, right? Negative 13 and 13. Now, let's learn about cubic roots. A cube root of a number is one of its 3 equal factors. So, if x cubed is equal to y, then x is equal to the cube square, or the cube root, the cube root of y. Okay, let's do it with numbers. Since 2 cubed it's equal to 8. 2 is a cube root of 8. Since negative 6 cubed, it's equal to negative 216. Negative 6 is a cube root of negative 16. Okay, let's see an example of this with numbers. Okay, every integer has one cube root. Okay, it doesn't have two like the square root. Cube root only has one. Okay, the cube root of a positive number is positive. So if I'm asking for the cube root of 27, I will have to find a number for which when I multiply it 3 times by itself, it will be 27. So if we do 3 times 3 times 3, will give us 27. So right here, my answer would be a 3. Now, what number multiplied by itself 3 times will give us 125? Okay, it will be 5. 5 times 5 is 25 times 5 is 125. Now, the cube root of 0, it's going to be always 0. Okay? So 0 times 0 times 0 is equal to 0. Now, the cube root of a negative number is always a negative number. Okay? So the cube root of negative 27 would be negative 3. Why? Because negative 3 times negative 3 is 9 times negative 3, it's equal to negative 27. Okay? So in this case, we're not going to have positive or negative answer. Either it is positive or negative. In this case, that cube root of negative 125 would be negative 5 for the same reason. Okay? Very good. Let's see an example of this. A perfect cube, it's a number that is the cube of an integer. Complete the table for the following perfect cubes. So the perfect cube for 27 is 3. And the perfect cube for negative 27, it's negative 3. Now, the cube for 64 is 4. Why? Because 4 times 4 is 16 times 4 is 64. But the cube root for negative 64 is negative 4. Okay, in this case, remember, we don't have positive and negative answers. Good. Let's continue. Example number 6 asks that we need to find the cube root of 125. In order to simplify the cube root of 125, you need to determine what number multiplied 3 times by itself is equal to 125. And we have it right here. 5 cubed, it's equal to 5 times 5 times 5, or 125. So the cube root of 125 is 5. Let's see another example. Let's find the cube root of a negative number. I already explained it, but let me explain it again. The negative number, when we ask cube root of a negative number, we'll get a positive negative number. So what number multiplied by itself 3 times will give us a negative 27? We have the answer right here. Negative 3 cubed, it's equal to negative 3 times negative 3, which is going to be 9, times negative 3 is going to be a negative 27. So my answer would be a negative 3. Now, let's use a cube root to solve equations. Dylan has a planter in the shape of a cube that holds 15.625 or 125 over 8. Now, let's remember a little bit how to turn a decimal into a fraction. In order to turn a decimal into a fraction, we're going to see the whole number. In this case is the 15. That will be like the big number. And then we need to look at the decimals before the whole number. It's 625. That number, we need to divide it by 1,000. Why 1,000? Because we call this one tenths. We call this one hundreds. And we call this one thousands. So this one has 3 decimal places, need to be divided by 1,000. Okay? Now, when we do it, we need to simplify it. Okay, how can we simplify this one? Well, we need to make a division. Okay? How many times can the 625? Oh, we need to simplify it, I'm sorry. So we need to divide it. If we divide it by 8, not 8. $125. If we divide 625 by 125, we get 5. And then if we divide 1,000 into 125, we get 8. Okay, so my number would be 15 by 8. We need to turn it into an improper fraction. So we multiply 8 times 15 equals to 120. And then we need to add this one. So it would be 125 over 8. So that's how we get to this part, okay? Remember, you can do it easier in your calculator. Good. Now, we now have that s cubed, it's equal to 125 over 8. So what do we need to do? In order to leave s by itself, we need to get the cube root of s cubed. We also do it in the other side. Whatever we do in one side, we have to do it in the other one. So we need to get the cube root of 125, which is 5. And we need to get the cube root of 8, which is 2. In other words, the 2 can fit in the 5 twice, and we have left 1/5. So, 1/5, no, 1/2. So each side of the container is 2.5 feet. Okay, that's how we do it. We can check the solution. S cubed, it's equal to 125 over 8. If we have we already know that s is equal to 5 cubed, 5 halves, we only cube that number. Okay, we replace it. The only thing we did was replace the s by what we know is s. Okay, so we affect both of them. 5 cubed is 125, and 2 cubed, it's 8. So 125 over 8, it's equal to 125 over 8. That's how we check it, right? Well, this is pretty much everything for this lesson. If you have questions, you can review the video again, or in next class, I can explain to you another way. All right? Thank you very much for watching, and I'll see you soon.